Hi everyone, today let's solve a Leetcode question called Subarray product less than k. So given array integer nouns and integer k, we want to the numbers continue subarray when product or element subarray is strictly less than k. So now example 1. Example 1, we have 10 nouns and want to find a product of nouns that's smaller than 100. And you see there are 4 single combinations, there are 3 double combinations, and then 1 triple combinations. Now let's check example 2. So example 2 has 3 nouns, and all of them are greater than 0. So there's no way to find the product between them that is smaller than 0, and we have to return 0, indicating we cannot find any subarray. Okay, now we have finished examples. Let's think about how to solve this problem. So for this kind of contiguous subarray problems, the best solution is to use the sliding window approach, which is efficient in time capacity memory usage. Let me show you how usage graph drawing here. So for sliding window approach, we want to start the left pointer and right pointer both at the beginning, right? So let's use this red one for the left pointer and another yellow one for the right pointer. Okay. Now the next thing is to calculate the product, which is all element in sliding window. Currently our product has to be 10 because it only one number 10 between the left pointer and right pointer. And let's check, okay, what's the relationship between 10 and this 100? We found, okay, this 10 is smaller than 100, right? So we have to keep expanding the right pointer to the right to search for a bigger product. However, the first thing to do before expanding the right pointer is to add the numbers to our result. So see, this 10 satisfy result requirements. So we add this 10 subarray to our result. Okay. Now finish that, we can actually move the right pointer right. So let's change this right pointer to next position. So it's 5. When we move right pointer to 5, our product should be updated from 10 to 10 multiplied 5. So our product currently 10 multiplied 5 equal to 15. And when 15 is still smaller than 100, this means our requirements is still satisfied at this step. If that case, we want to include 5 into our result array. And we also want to include 10 and 5 because it's a combination between these validated elements, right? And after that, we can move the right pointer further to the right position. So just change it out, and let's move the right pointer to this position. Okay. Now we want to recalculate the product. I'll change it out here and write it here. So far, the product is 10 multiplied by 5 multiplied by 2, so it's 100. And 100 is actually equal than 100, so we found these requirements of the equation is not satisfied, and we want to expand the left pointer to the right position, right? But before that, let's include 2 into our result array because this single element still satisfied the result. Okay, so add 2 here, and we also want to add 5 and 2 because this double element satisfy result. But we don't want to add these triple elements because it does not satisfy the result at the current step. Okay, now finish that, let's move in the left pointer right so we can shrink the windows for smaller products. Okay, so left pointer is moved to this position and want to recalculate product right. So current product is 5 multiplied 2, and you see it's 10. And 10 is actually smaller than 100. If that case, we want to move the right pointer to right position, right? Okay, so we're moving this right pointer to the right position. Now the right pointer is at the last element of this array 6, and I want to recalculate the product. So the product will be 5 multiplied 2 multiplied 6, and you see here we get 16, right? But 16 is still smaller than 100. And it should be the case we have to move the right pointer, but here the right pointer is already at the end of the array, and we cannot move this any further. So we have to stop here and count all the combinations. So for the combination here, the first thing to consider is the single 6, right? So single 6. Next to consider is 2 and 6. And finally, we have to consider these 3 elements because this 5, 2, 6 also satisfy result. So add this subarray to result, and totally we have 8 subarrays. It should be done. Okay, now finish the explanation. I hope you have gained some intuition of this question. Now let's dive into the coding part. Okay, so first let me write out the general framework, and then I can show you the coding comments and the Python code. So just copy paste the coding comments from the intuition, so we can save some time and make less mistakes for the later part. Okay, the first thing we have to consider for sliding window approach is the left pointer, right? So left pointer was starting at 0, indicating at the beginning array. And the next thing we need is product was starting at the 1, and we need a combination. So it will be starting at 0. Okay, now we actually run the sliding window approach from here. So for the right pointer, we want to move all the way from the beginning to the end, right? And if we're moving the right pointer to beginning and end, we are gradually expanding window. So next thing you calculate the product. Every time we want to modify the products, when the numbers are right, so we are growing the product to a larger number. And if found, okay, while left is still smaller equal to right, this means this sliding window is still hold, right? And what? And if our product exceeds target, it means it's greater than equal to the target, and target k, right? If that case, we want to divide product and want to shift the window by moving the left pointer to the right. So divided the product by the left element, shift the left pointer to the right. Okay. Now finish that. Next thing to add the new combination, right? So our new combination will be right minus left plus 1. Don't worry, I'll explain later. And combination will be added by new combination. And finally, we'll return the combination. So actually, you can simplify this code here to write like this. Okay, let me explain why the new combination will be right minus left plus 1. And you see this example, we are moving the window from 1, 2 to 1, 2, 3, right? So see only 3. This 3 is the new element in the new array. And the new combination, we can take it either this 3 and this 1, so get this 1, 3. Or we can take these 3 and these 2, so get 2, 3. And also we can take these 3 with all these 2 numbers, so get 1, 2, 3. So actually you see here, if we write it out at the right pointer minus the left pointer plus 1, it also be 3. And there are totally 3 new combinations. Okay, I hope my explanation will make some sense. Maybe you can use graph joining yourself to help you understand. Now finish the coding part, let's submit the result to see it works. Okay, you see the time capacity memory usage of this solution is not bad, right? And the code is short and easy to understand. If you find this video helpful, please like this video, and I'll see you next time. Thank you.